this is Lemis Dengir from Knowledge and Skills, and today we are going to talk about non-traditional machining processes. First of all, we are going to talk about the differences and common points between conventional machining and non-traditional machining. Then we will see the different technologies used for chemical and electrochemical processes, then the mechanical processes, and finally the thermal processes used in NTM. By definition, machining is one of the secondary manufacturing processes by which excess material is gradually removed from a pre-formed blank in the form of solid chips, using a wedge-shaped cutting tool in order to get desired shape, finish, and tolerance. It follows subtractive manufacturing approach to fabricate desired object. Examples include turning, threading, facing, drilling, boring, milling, etc. Such conventional machining processes are unable to cope up with the ever-growing demands for miniaturized products with high surface quality and close dimensional tolerance. Moreover, newly developed materials display unacceptable machinability in many occasions. All these limitations paved the way for finding out alternative machining processes that can satisfactorily process wide variety of materials and produce surface finish in the range of nanometers with improved accuracy. Subsequently, many non-traditional machining, NTM, or unconventional machining processes have emerged that to cater the need of markets. In non-traditional machining processes, neither shearing occurs nor shapes form. In fact, such processes don't even utilize so-called cutting tool. Instead of only mechanical energy, various forms of energy, mechanical, thermal, electrical, chemical, electrochemical, light, etc., are used in their direction form in such NTM processes to remove material. Materials removal is also realized in several ways, such as by erosion, melting, vaporization, ionic dissolution, etc. There are several NTM processes. We will see them in this course. Each process has distinct capabilities and is suitable for specific purposes. There are similarities between conventional machining and non-traditional machining processes. Indeed, both are machining processes and those used for removing excess material, and both are subtractive manufacturing processes using the top-down approaches. Both are secondary manufacturing processes, of course, and can produce sufficiently smooth and finished surface with close tolerance, although different processes have different capabilities. However, there are some differences between the conventional machining and the non-traditional machining. Indeed, in conventional machining, only mechanical energy or power is utilized to gradually remove excess material from the workpiece. However, in NTM, various forms of energy like electrical, mechanical, thermal, chemical, light, etc., or a combination of two or more such forms are directly utilized to remove excess material. The second point is that in conventional machining, materials are removed in the form of tiny sharp chips. However, in NTM, the so-called chips are not produced here. Indeed, the material is removed in various forms such as tiny metal particles, ions, molten or vapor, etc. The third point is that in conventional machining, shear deformation till fracture is the only phenomenon that causes removal of the material. However, in non-traditional machining, shear deformation plays a non-significant role in material removal in most of the NTM processes. Indeed, erosion, dissolution, evaporation, sputtering, etc. occur here. Another point is that in conventional machining, a sharp wedge-shaped cutting tool having specific geometry, material, and properties is required for cutting action. But in NTM, the so-called cutting tool does not exist here. However, in few cases, for example, electrochemical machining and electric discharge machining, the tool is required and its profile and property must match with the requirements. The last point is that in conventional machining, physical contact between the cutting tool and workpiece and also relative velocity in between them are indispensably necessary in order to remove the materials. But in NTM, although no physical contact occurs between the cutting tool and the workpiece, in few processes such as abrasive jet machining, abrasive water jet machining, and ultrasound machining, solid abrasive grids strike the work surface to erode material. Conventional machining processes are age-old and thus physics of the processes are well understood. Moreover, skilled laborers are also readily available at comparatively cheaper costs. Nevertheless, for non-traditional machining, most of these processes are developing, and labor cost is also high due to a less number of skilled labor available in this field. Then, for conventional machining, a wide range of surface finish depending on the process. Superfinishing quality inferior than 10 micrometers requires costly CNC systems. But for non-traditional machining, achievable surface finish is much better than that for conventional processes. It can easily provide a surface finish in nanometer range. After that, conventional machining processes are suitable for bulk removal of material. In this sense, these are fast, reliable, and economic, and they provide obviously higher material removal rate. However, for non-traditional machining, these processes are suitable for highly accurate and precise requirements. And for bulk removal of materials, these processes are time-consuming, less reliable, and uneconomic, so we don't use them generally for bulk material removal. Finally, there are certain shapes that cannot be produced by conventional machining, while NTM processes sometimes become a reliable option for producing such critical shapes. Thank you for watching this first part of the course Non-Traditional Machining Processes, and in the second part we will see together the electrochemical processes. I hope you enjoyed this presentation and see you next time.